Hello friends, how are you? I hope that you all are well. Today in this video, I am going to explain about LAMI'S theorem. This is my 11th video. I hope that you might have subscribed my channel. If you have not done, it's better you do. As a result, you can get the notification in right time. So let us start. What is LAMI'S theorem? If three vectors are to 0, suppose three vectors are there, we are adding, it became 0. If three vectors are to 0, the ratio of magnitude of each vector to the sine of the angle between two other vectors is a constant. It is better I shall write here. See here. When three vectors are to 0, ratio of magnitude of each vector to the sine of the angle between other two vectors is constant. What I written? When three vectors are to 0, ratio of magnitude of each vector to the sine of the angle between other two vectors is constant. It means suppose P is a vector, Q is a vector and R is a vector. When three vectors are to 0, during that time ratio of magnitude of each vector, this is the magnitude of vector P, to the sine of the angle between other two vectors. Other two vectors means the angle between Q and R. This is also equal to Q to upon sine of the angle between P and this is also equal to R upon sine of the angle between vector P and vector Q. This is the statement I have written mathematically. The ratio between magnitude of the vector P to the sine of the angle between other two vectors means Q and R here other. Here Q between P and R. Here R between two other vectors means P and Q. I have to prove this is the LAMI'S theorem. This one I am going to prove it. Okay children, let us see here. So I am wrapping it. This is the statement. So now it is given P plus Q plus R. All these three vectors are, we get 0. This is the condition is given. So I can write that implies that vector P plus vector Q is equal to minus vector R. Okay. Now what I am going to do here, I am multiplying both sides with the vector P with cross product or vector product. That means P plus Q is equal to minus vector P cross vector R. Both sides I multiplied. I did the cross multiplication or vector product. I have taken P both sides. So it implies that you know that P cross P both are the parallel vectors. Both are the same vectors. I can consider parallel. Here sin theta means sin 0 degree. This product will be equal to 0. So I can write here P cross Q is equal to minus P cross R. Okay, since P cross P is equal to 0. So now I can write that vector P cross vector Q is equal to R cross P. We know that vector product is not commutative. So in case of minus P cross R, I mentioned here R cross P. So this is equation 1. Now you see that another equation I am making. So this is P, this is Q, this is equal to minus R. Now what I am doing, I am multiplying vector Q both sides as a cross product. That means Q cross P plus Q is equal to minus Q cross R. Implies that Q cross P is equal to minus Q cross R. Okay, why? Since here Q cross Q cross Q is equal to 0 because the angle between them is 0. We know that sin 0 degree equal to 0. This is the vector product. We know that if A and B are the two vectors, then the magnitude of their product A cross B mod is equal to AB sin theta. I am using that one. Implies that. So I can write minus P cross Q is equal to minus Q cross R. Okay. Since what is the reason? The reason is that okay. Here it's clearly written Q cross P is equal to minus P cross Q. This is the vector product. I said vector product is not commutative. Implies that P cross Q is equal to Q cross R. Both sides मैंने माइनस साइन हटा दिया. I remove the minus signs both sides. Okay, this is the second equation. Okay, I got here P cross Q equal to R cross P. Okay, here I got P cross Q is equal to Q cross R. That means from equation 1 and 2 we get P cross Q is equal to Q cross R is equal to R cross P. Now what I am doing here, I am dividing P Q R. Okay, otherwise I can write here P cross Q mod is equal to Q cross R is equal to R cross P. Both sides of the equation I took modulus. Okay, so children, I am drawing this portion. Okay, So now I can write that this is PQ sine of the angle between vector P and vector Q. This is equal to QR sine of the angle between vector Q and R. This is equal to RP. I have written here magnitude. This is the modulus magnitude we are taking. RP sine angle between R and P. Okay. So dividing both sides of the equation by PQR, we get what we get. You see that I am writing PQ sine of the angle between P and Q is equal to QR sine of the angle between vector Q and R. This is equal to RP sine of the angle between vector R and P divided by PQR. PQR, this is also PQR. So this PQ cancel, QR cancel, this RP, this R and P both are cancelled. So now I can say that this is sine of the angle between P and Q upon R is equal to sine of the angle between Q and R to the P. This is equal to sine of the angle between R and P, or P and R doesn't matter, divided by Q. Okay. So implies that I can write that R upon sine of the angle between P and Q is equal to P upon sine of the angle between Q and R. This is equal to Q upon sine of the angle between R and P. So the theorem is already proved. So I hope that you might have understood this theorem clearly. Okay, once again the result I am writing here. So P upon sine of the angle between the vector Q and R is equal to Q upon sine of the angle between vector P and R is equal to R upon sine of the angle between vector P and vector Q. Yes, what is that? Same thing I have written here. This is the LAMI'S theorem. This proved. I hope that you might have understood this theorem properly. Let us see another concept. Children, don't forget to share this video with your friends. As a result, they can also get the benefit. At the same time, don't forget to comment on this video. If anything is there, definitely I shall try to do better in my next video. So now I am explaining about area of a parallelogram. Okay, area of a parallelogram. Now you see that, suppose this is O, this is P, this is the Q. This OP represents the vector A, OQ represents the vector B. I am completing this parallelogram. Okay, suppose this is R. From this point Q, I am drawing one perpendicular. Suppose this is normal or perpendicular to this side OB from the vertex Q. Now I can say that, okay, suppose here P OP RQ is a parallelogram. OPRQ is a parallelogram. Now you know that area of a parallelogram is equal to product of one of its side and the perpendicular drawn from the text to that side. Okay, so I can say that here area of the parallelogram, this angle, suppose they are making the theta between A and B. Area of the parallelogram OPQR, here I can say that this is the vector OP dot. This is a dot product because the area is a scalar quantity. So I am taking OP, okay, and QN, okay, or better I can write this is as OP, sorry, the magnitude OP dot magnitude QN and the sine theta. Okay, because this is the dot product of the side OP and QN. OP and QN. So this is the magnitude. So I can write this is OP dot QN sine theta, or I can write in place of OP, I can write like this: vector A cross vector, sorry, I can write A B sine theta, AB sine theta. Why? In this case, since QN is equal to B sine theta, B sine theta, you know that sine theta is equal to P by H, or P equal to H sine theta. So in place of this side I am taking B sine theta, or I can take this is AB sine theta, or here I can take it as vector A cross vector B. Okay, because I have mentioned here AB sine theta, I can take it as the magnitude of cross product of vector A and vector B. So from this equation what we go get? we get that vector product, the magnitude of vector product of two vectors is equal to area of a parallelogram with two vectors as the adjacent side. So I can write that from the above result we can say the magnitude of cross product of two vectors is equal to area of the parallelogram. Area of the parallelogram with two vectors as the adjacent sides of the triangle. See that A and B are the adjacent sides of adjacent sides of the parallelogram. That means we got the magnitude of A cross B is equal to area of the parallelogram where vector A and vector B are the two adjacent sides of a parallelogram. One more concept we see about the area of a triangle. I am rubbing it. Single area of a triangle. Area of a triangle. Now, okay, O P Q. This is the QN. Here OP represents the vector A, OQ represents the vector B. This angle is the theta. Okay. Now you see that area of the triangle OPQ is equal to half into base into height. Here base is the OP. Here to here. Sorry. OP into QA. I'm taking the magnitude. Area of the triangle. Simply I have written half into base into height. So I can write that this is half. Okay. So in form of the dot product, I can say this is half into vector A, vector B, and the sine of the angle between them. In place of this QN, I am using sine theta. That means Here better I shall write vector A dot vector B. Sorry. This is correct. OP dot QN, or I can write half. In place of OP, I can use the A, and in place of this QN, I can use B sine theta. B sine theta. Yes, it is the dot product. So I can write this is half magnitude of A cross B. Clear? This is the area of the triangle. From this formula, what we get? So, from the above result, we get what we get from the above result. We get area of a triangle is equal to half of the magnitude of cross product of the two vectors as the sides of a triangle. See that vector A and vector B as the sides of a triangle. We found half of the product of or half of the magnitude of the product of cross product of two vectors A and B is the area of a triangle. So children, I hope that today's class you might have understood. If anything is there, you comment definitely. In my next video I shall try to answer it. Until my next video, bye.